Hey everybody, it's Paul Ramsey back with Dr. Manny St. Victor for another episode of Hypnotic Thoughts. Manny, how are you?
I'm doing great, Paul. How you doing, man?
Good. I'm really excited to talk with you about today's topic, and I'm also a little intimidated. I'm not going to lie, because there's a lot going on, but I just have this instinct that it feels important um, that this one article that I stumbled onto could lead to a lot of other discussions. So I think what I'm going to try to do with your help is I'm going to sort of represent what I think most people who don't inhabit your world would think about and ask questions about. And let's just get started today and then see if we probably need to do follow-up episodes, but let's sort of do a foundational episode today. Is that okay?
Absolutely.
Okay, so here's the deal. This article, not really an article, a study that I sent to you, 2003, 2006. 2006, Neuroimaging and Genetic Associations of Attentional and Hypnotic Processes, by Amir Raz, Jin Fan, Michael Posner, and some other folks, I guess. So they published this study that they did where they looked at high hypnotizable people versus low hypnotizable people, and they gave them cheek swabs and actually ran their DNA and looked for certain genetic markers to determine if your level of hypnotizability is actually coded genetically in you, which I had never thought of until I found this article. It was amazing to me. I mean, and then once I got to thinking about it, I was like, well, everything else seems to have some kind of genetic link, right? So why wouldn't this? But I just hadn't really thought of it before. All these years, I'd always been thinking more about maybe it was the way people sort of encountered or developed skill sets and resource sets in their mind and stuff over their life. I didn't think about it coming down to just plain old genetics. So first of all, that's where all this started. Now, so we get to this section where I gotta read this. I gotta read it. So it says, we compared variations in hypnotic susceptibility among healthy volunteers with differences in multiple dopaminergic genes from contributed DNA. So first of all, what is dopaminergic? I mean, clearly it has something to do with dopamine, but it's a different form. So what is dopaminergic?
It just means dopamine tracks, is the way I think of it. Just tracks that are involved with dopamine, like use
Okay.
dopamine for transcription, for communication.
Okay, so
Now, the
genes that have a specific function then related to dopamine somehow.
yeah, and where this becomes important is, and they mentioned this in this article, there are three components to something getting your attention and startling the crap out of you. There's an alert feature, and the alert feature is associated with norepinephrine. That's fight, flight, freeze. Like, you know. Now, when you alert, there's going to be a second step where you orient. Okay. Now, when you orient, your attention comes in like click, click. That's acetylcholine.
Okay.
And the first one was norepinephrine. Now, once you've oriented, and you're going to want to fixate and process what you're seeing, and that's the mesolimbic dopaminergic, cortical mesolimbic dopaminergic.
Okay.
So that's where dopamine comes into play. It's once we did a video a while back on ACC, anterior cingulate cortex,
Right.
and how it was used in conflict resolution. So we'll
Right.
probably link it to this later. But your dopaminergic tract is involved with your ACC and your LPFC, your lateral prefrontal cortex.
So yeah, so we talked about in our old series, we gave one episode just to talk about dopamine, and we mostly talked about how it affected reward-based behaviors and functions, right? And
Exactly.
but now we're sort of connecting that further to rewards as they somehow affect your attention in this case.
Your rewards, punishments, any changes, and any surprise element. Because that's when you go out of autopilot. It's surprise, some sort of surprise.
Well, so now the autopilot thing. This is another interesting. Well, we'll talk about it. I'm going to hold off on that, and we'll do another episode specifically on attention, but I want to stay focused. There's so much here that I have to work hard to say. So, so they sampled people's DNA, they look at the dopaminergic genes, and then they find, it says, in line with data by Lichtenberg, which is a 2000 study that had sort of informed what they were trying to do, we found a polymorphism in the COMT gene to be related to hypnotizability. All right, what's a polymorphism?
Well, you have two copies of any, two alleles of any gene, and they could be the same. And in this case, it could be val-val, which is valine, or met-met, which is it methionine? I just remember the M. After a while, you know, it was
methionine. Yeah,
methionine. Yeah. So when you have a val-met combination, the met is less effective at transcription of COMT, which is catecholamine or methyltransferase, which means it transfers a methyl off of catecholamine. Now, when you zoom in on what that means is when a COMT is producing a lot of this, it's producing a lot of the val version. Well, when there's a val version, it produces more. And so you're going to have more of this enzyme that breaks down dopamine in the synapse. So you're going to have less dopamine.
Okay. Okay.
And since it's two strands, if one of your strands is producing less, then I'd say you'd have about, not really 1/4 less, but you'd have less dopamine than if you had both that were met, which would be way less dopamine.
Okay, so you're saying there's two strands. Some people therefore have like more, they have one strand but not the other, or they have more of one strand than the other?
Well, imagine that there's two chromatins, like two alleles walking side by side. Okay, like I'm trying to create a spiral, but in 2D. But so if one of them has a val, it's going to produce a certain amount of COMT.
Yeah.
If the second one has a val, it's going to produce a certain amount of COMT.
Yep.
If you decrease if you replace the valine with a methionine, then you're going to get less. And it's not necessarily half, but let's say half, just for visual. One of your guys is producing half as much COMT.
Uh-huh.
Okay. Now, since COMT is the enzyme that breaks down dopamine in the synapse, when you have less of the enzyme that breaks it down, you're going to have more dopamine.
Okay, so this is where it goes to next. Now I think I'm getting, so the next thing is, it says specifically, valine, methionine heterozygous subjects were more highly suggestible than val-vals or met-mets.
Yep.
So you're saying because they had 1 and 1, they got more dopamine kicking around.
Yeah.
Okay.
Yeah.
So somehow these researchers are saying that makes them more hypnotizable.
Yeah. And I took a look at that, and they pointed out a characteristic. They said that I got my scripted notes, and that doctor writing is hard to read, even though I wrote it. People who are highly hypnotizable, they produce more words. They produce their words more automatically. Now, if you take a step back from here and think about what it means when someone produces a word implies that your brain has taken two subconscious entities and created a thought, and the thought has bubbled up. It's like a thought automaticity. Okay?
Okay.
Now, so some people infer meaning from a situation more quickly. Words are concepts, or bound to concepts. So it means that something in your brain decided that a situation had a meaning. Something became conscious. So highly hypnotizable people are more likely to manifest conscious awareness of a word and therefore of an idea. So it's a perception thing almost.
Okay. Okay.
Now, did that make it clearer or muddier?
Well, it's both in some ways. Like, so I'm like, okay, so I get that, but I don't quite get why, and I don't want to ask you why, because then I know that's gonna jump you off into a whole other direction.
It's conclusion. It's when someone is uncertain about something, suggestion is all about attention direction. If you and I are looking around somewhere and I say punch buggy, like Volkswagen Bug,
Yep.
your attention suddenly centers on the Volkswagen because I said the word.
Right.
Okay, now if everything else goes into background, the Volkswagen gets foregrounded. Until that word emerges, that thing is not foregrounded. It's not the center of your attention.
Right.
So a person who is more hypnotizable forms the words faster. The dopamine shoots across and sends the signal, go faster. You know, we also have elevated dopamine in schizophrenics, and sometimes in Parkinson, you have decreased dopamine. So you see how the two extremes can play a role in your ability to process a thought, come with an idea, even in motion.
Okay. Okay. So, do you feel like, based on what you read in this article, that this isn't just like sort of a, do you feel like what they share here really does strongly suggest that hypnotizability is powerfully influenced by genetics?
Yes.
Yeah.
Yes. And taken further, the COMT is also the locus associated with when someone is raised in a traumatic environment, the likelihood that they will end up an aggressive or violent person is also something that's found on this Valmet dichotomy. So it looks as if overall you can use a theme of environmental susceptibility.
Okay. So does but now the way that you just framed that then I would say, okay, but you're saying, so when that child is born and then raised in an environment that actually changes the way it's growing its brain, right? So with plasticity, could we help people become better at being hypnotized and help them activate more of the genetic resources they have, or change the epigenetically, like change things and become more hypnotizable? I know that's
I think what you're looking at is the answer would be yes, you can change someone to become more hypnotizable, but what you're doing is improving their ability to pay attention, which I would assume is decrease their level of anxiety.
okay.
Because increase their level of trust.
Yeah.
Because when you increase the level of trust, you're increasing the oxytocin and you're building more rapport basically.
Yeah.
And when you're building the rapport with that person, they listen to you and you're going to get a higher absorption of the information.
Okay.
Because there's less of that.
Help them make better use of what dopamine usage they can have without having other transmitters and stuff interfere with that process.
Exactly.
Other processes which would fire off other transmitters which could get in the way.
Yeah.
Okay. Okay. All right, that makes sense. Cool. All right, so so that's it for this one. Let's stop there. We'll post this for you guys. You can review this and re-listen to it if you need to, and we will post a link to the study. And then we're going to come back in our next episode, and we're going to focus on the other aspect of this study, which was what they also were really looking at is how do people pay attention and how does attention work? So we're going to build on this by coming back and focusing more specifically on attention and how attention works. So that's what's next for us. Come back and join us. Thanks for joining us today. I'm Paul Ramsey.
And I'm Dr. Manny St. Victor.
Don't leave me hanging.
Dude, I was reaching for the mute button because, Imani was practicing solo in the background. You know how she gets.
Thank you guys for joining us. We'll see you again soon. Bye-bye.